All right, let's see if you guys are all paying attention here. You guys ready? Booyah! Are you ready? Okay, good. All right, class. Woo. Okay, not bad, not bad. Kind of weakness coming from that zone back there. Not implying that anyone in here still has their earbuds in because everyone's going to be paying attention. Almost like there's something super important coming up. Now, when's the last day you could turn in any work for me? Next week. On Wednesday. Did you guys just check your grade right now? If you just checked your grade right now because you were supposed to be updating your SMART goals by checking your grade, are you graduating?
Yes.
I know you are. You good. Okay. A lot of people, if end of the quarter is next week, if your grade is not in the passing range, I'm gonna have to hand out some summer school applications already. That's crazy, right? I know. But some people still have a single digit grade.
Single digit?
Single digit. That means a grade less than 10. All right. Now listen. This is all going on my video, so you guys actually know what's coming up. Even those people that are sitting at home trying to watch my video. Now, you need to use your numworks here. This is actually going to be easy as long as you follow along, pay attention, take good notes for this, because we're going to do some statistics or regression type stuff that I need you guys all paying attention to. So let's start off right here. So the role of E in applied exponential functions. An irrational number symbolized by the letter E appears as a base many exponential functions. The irrational number E is about 2.721828, blah blah blah. Now, anyone know what irrational means? Very good. It's not rational. Okay, so someone explain a little bit better. Explain it as if you were talking to Edgar over there that can't seem to put his earbuds away. So what does it mean? Explain it as if you're telling Edgar. Number 5. Very good. Good job. High five yourself. Yes. So pi is an irrational number. Okay, so what about it? What about it makes it irrational? It's a decimal that's continuous and never ends, and it also damn, you're right. But it also doesn't repeat. It does not repeat. It does not end, it does not repeat. So it's a irrational. So like this, 2.71828, blah, blah, blah. And it keeps going on, just like pi. But this time we're using E as that number to represent this. The number E is called the natural base. Natural base. The function f of x is equal to e to the x is called the natural exponential function. We're going to use this a lot, especially with our logs. All right, alcohol and the risk of car accidents. Medical research indicates that the risk of having a car accident increases exponentially as the concentration of alcohol in the blood increases. The risk is modeled by R. R stands for what? Risk, thank you, is equal to 6 times e raised to the 12.77x, where the x is a blood alcohol concentration and r gives as a percent, is the risk of having a car accident. In many states, it is illegal to drive with a blood alcohol concentration at 0.08 or greater. What is the risk of a car accident with a blood alcohol concentration at 0.08?
What was this equation on Saturday?
Yes, this is your equation on Saturday, right? Now, for all those people that drive around, got that 40 ounce, right? In the brown paper bag as you're cruising. I went to Circle K this last Friday, and they made a big deal of, some guy made a big deal that they didn't have any brown paper bags.
Oh, I hate that.
He didn't have any brown paper bags because he wanted to drink his beer while he's driving, and he got mad at the lady at Circle K. Yeah, if you have an open container in that in the car at all, and you're drinking and driving, guess what? That's all automatic DUI. Automatic. It's almost like automatically get yelled at for having an earbud in, even though that I'm standing right here. I know. So, for right here, we're going to try and find the percentage for this. Substitute 0.08 for x in the function. So my r, which is my percent, equals 6e raised to 12.77. And I'm going to put my x value in parentheses because it makes my life easier. And 0.08, close. And we're going to solve for that. So you're going to pull up your numworks. You're going to pull up numworks, and you're going to enter this into calculations. So before I get too far into this, I want to see you people actually trying it for yourself. So, under calculations, your calculator, your numworks calculator, okay, go to calculations, and the E exponential is right below the shift button. Right below the shift button. Where's it at? Very good. Did you find the calculator yet? Okay. Can I see it? Look at that. Yeah. Who's a good boy? You are. Yes, you are. All right. So I'm going to go through here so you guys could actually see it. So, calculations, 6e raised to the 12.77, open parentheses, 0.08, close parentheses, and okay. All right, who's a good boy? There you go. I went to one of those little vending machines for a quarter. Yeah, I was like, you know what? That would be a good one. Good boy part. All right, anyone having trouble getting there? No one has trouble? Everyone got this? Look at you! Actually, someone messed up. Good. Booyah! Why you not doing this? Why is Booyah not doing this? Hey, does he understand English?
He does.
He does? Then why is he not listening?
I don't know.
Understand the words that are coming by my mouth. Go to the calculator. Man. All right, so R is going to represent 16 point, let's say about 7. It's going to be about 16.7. Now, what was it that the R represents, though?
Risk.
Risk as what?
Blood pressure.
Oh, no. Read through the problem. Read through the problem again.
Where's the car accident?
Yeah.
As a, I heard it, percent. So you have to read through there to see what the R represents. So in the word problem, it actually says the R represents the chance of a car accident in percent.
Oh, is that low?
As percent, look. Right here, it says R given as a percent is the risk of having a car accident.
The concentration guideline?
Yes. So what this is saying in plain English, if you are driving, you have a blood alcohol concentration of 0.08.
So that's just the legal limit.
Yeah. So, but the math on this says that it comes out to be about 1 out of every 8 people that drink and drive with a blood alcohol concentration of 0.08 has a car accident.
They use breathalyzer to make
Yeah,
right?
they can do breathalyzer, they can do other things too. But now, since no one stops at 0.08, like AJ this last weekend, you know, he stopped after like a whole case and he couldn't get back up. So his blood alcohol content was 1.8.
There should be another
1.8. So what would AJ get with that 1.8?
They should ban it.
Oh, he's going to jail. And we said his blood alcohol is 1.8. That's how much he was drinking. Okay? There's a 576% chance that he is going to end up. Yeah. Wait, hold on.
They don't have
No,
Wait, hold on. Wait, no, that's even worse. It's e to the 10. All right. 1, 2, 3, 4, 5, 6. Wow. That's like 500,000% that you are going to get in a car accident. Guaranteed. That's guaranteed. Now, since AJ's not going to do any more drinking and driving, right? Okay, turn over a new leaf, right? Straight edge. Okay, no more drinking. Now, the next thing that we're going to have is modeling using logarithms. Modeling using logarithms. You guys did this back in Algebra 3-4. I know you did. You might not have remembered it. You might not actually even paid attention for most of it. But that happens a lot. I know it does. Because there's people right now looking at their phones and not paying attention to me. Because their earbuds in. And staring directly at the phone. Put the phone away, bruh. Thank you. You just texted him too, just to get him in trouble. What a good friend. All right, so now we're going to actually take a logarithm, which is y equals log base b of x. And it's going to be equivalent to the exponential function of b raised to the y equals x. So they could be interchanged back and forth. So whenever I do this, I could just say, hey, x, come on, x equals, and I rewrite it to whatever value this is, whatever my base goes next. So b, whatever the base value is, raised to the y. And we're going to do this more here in a little bit. So you'll see, it'll go back and forward on these. So it's exponential. All right, so we're going to go through and we're going to start this, but we're going to start this by graphing. So now, we were in the NumWorks calculator. Now time to go to the graphing. So let's bring up the NumWorks and put that in there for graphing. Log base 2 of x. This one's going to take a little finagling. Finagle is the official word. Go to grapher. Add empty. Y equals log. It is right here. But now it automatically gives you log base 10. So I don't want base 10. So all I have to do is arrow back right here. And what do I want as my base? 2. Just put it in 2. There you go. That's all you got to do. And you know it is correct if it says equation. Now, are you guys writing good notes for this? Because you're going to have to do this again coming up real soon. This class is, what is this, 5th hour?
Yeah.
Okay, so you're going to be having the test on Thursday.
This is?
Yeah.
What the fudge?
What's happening next week? Everything is due, and then after that is fall break. So the end of the quarter is next week. So we're testing now, and if you need to retake the test, you have next week to try and get it in. Yes. Yes, it does, but the gradebook closes for anything else. So let's say, for instance, I have a kid like AJ in my class. He hasn't done anything since week 1. Okay, he still hasn't done the cover on his notebook. That was the first assignment I gave you guys. That was the week 1, right? AJ's going to try and turn it in December. And do you know what that's going to be? That's going to be like really hard on not just me, but him. Because now he's got to try and figure out how to do it because he waited to the very last minute. So don't be an AJ. So anything you have due has to be done now. And then whatever your grade is at the end of the quarter, you pick up from there. It's just you can't do any more, turn in anything else from this quarter. Yes, that guy. Yeah, go ahead. All right, so let's go ahead and take a look at my graph. Bam! There we go. I know, right? So now I have the equation, and now I'm going to start plugging in stuff for my values. So let's go back to the notes. And so this first one right here is going to be x. This is f of x, and that's x comma y. So we're going to plug in some values to see what happens here. So let's start by plugging in -1. Plug in -1 onto the grapher just by typing in the negative in 1. Just type in -1. What do you get if you type in -1? Yes. See, I'm using the same thing, but it's weird that yours doesn't have it. All right, did anyone tell me what they got at -1?
Where do you plug -1?
What'd you get -1? Negativo uno. So I brought up the number 1, so -1, right there. So if you notice down here on the bottom, in my x value, it says -1. What is my answer there? What's the answer? Undefined. So let's take a look why. Look at my red line. Does it exist over here at -1? It doesn't exist there, so therefore it's undefined and -1. All right, let's try it again. This time, let's try it at 0. Let's see what we get at 0. Come on, 0. What do we get at 0? Undefined. Hey, doesn't it look like my red line is touching the 0 though? What's it called if it looks like it's touching it, but getting really close? A teaser? A what? No, not parallel. It's getting really close to it, but not touching. Nope, try again. If the line is getting really close to a number, but not touching it. No? Hmm? A. No, what's it called? Come on, Sebastian. I got more than 2 people in this class, and I know some people. Ascending? Nope.
Is that an asymptote?
Are you like trying to fast forward or something every time? Say it again. Asymptote. Kiss my what? Asymptote. Because you're not touching it. You're not touching it. It approaches it, but it does not touch it. So it is, the red line is going to an asymptote. So it really doesn't touch that line. So that's why it is undefined right there. All right, so we now know that that one has an asymptote there, so it doesn't exist. It is undefined. Let's try the number 1. Now plug it in. Just type in the number 1, see what you get. Okay, 0, very good. So now that this one does exist, I can now put it over here, 1, comma 0. 2. What'd you get?
1.
1. All right, so now,
That's 1 isn't it for y?
yes, 1's the y.
Okay.
All right, so the next one, I'm going to show you something, so I know you guys are all paying attention. I'm not going to 3. I'm going to 4.
What?
What do we get?
2.
2. Okay, so let's see if you guys pay attention at all and can recognize a pattern. What's the next x value I should use? Is it 6 or 8?
8.
It is 8.
It doubles up.
8, what is my y value going to be?
4.
Ow!
It's 3, not 4. Okay, now why is that?
Oh, never. That's not. Actually,
My base value each time was 2, wasn't it?
yeah.
So 2 to the first power is
Just
2. 2 to the second power is 2 to the third power is
8.
there we go. And that's rewriting this in the other form. X equals 2 raised to the y. That's rewriting it using exponential notation from my logarithmic notation. Are we good? So that's where we get those from. Now let's go ahead and try a scatter plot here. Just for the sake, I'm going to tell you the numbers because last time we did this, no one could read it on their paper. So my numbers are going to be 10, 19, 20, 29, 30, 34, 40, 38, 50, 41, 60, 43. So write these down because it's going to make your life easier. It's kind of hard to see on the graph on their paper. And as soon as we're done with that, we're going to go and do the regression like we did on Friday.
Put it all the way away. I'm trying to tell you.
What? Huh? No! I can't. I could. But what if I care that you are not going to be passing my class because you're not paying attention? You get distracted every time you get a notification and not listening. Come on, this is our time. Remember? It's our time together. You don't go on a date and put in earbuds and like pretend like you're paying attention to that person, right? You do. That's why she left you at the restaurant and made you pay. All right, so we're going to go through on our numworks and we're going to add these coordinates to our regression just like we did on Friday. All right, so numworks. Home. Go to regression. Okay. And we start entering our values. Please start entering your values. 19? It was 1019, right? And it was 20. What was the next one? 30. 34. 40. 50. 41. 60. Now, this is the same thing we did on Friday. Same thing we did on Friday. So if you're looking at your notes from Friday, hopefully you're following along. Let's go up to the graph and see what this looks like. Ooh, look at that. Serious question. Is that a straight line?
No.
No, it's not a straight line. So that's not linear, is it? No. So, according to my information here, it says that I want to do a logarithmic model, which is a plus b ln x. So let's go up to regression, because I know you guys wrote these notes down on how to do this, right? You go to regression, and we find a plus b ln x, right? Dang. All right. Now, is that close? Is that really close to all of them? That's really good. That's what I want. It's really close to all of them. Okay, so now let's go to the information about this regression. So hit regression one more time. Look, there's my equation and my R values. Why is R value important? Edgar, do you remember from Friday? Why is R value important? No clue. Uh-oh. Can someone help out Edgar? What was the R value and why was it important? What do we have? I know we have. So, what's it mean? Yes. No, that was the previous one. That was the risk one. This R value here. We had this note on Friday. What does the R in this thing stand for from Friday? Do we have notes from Friday?
Yes.
Did we write stuff down in my notas for Friday? We did. What? The regression line. Okay. Now, what is important about the regression line? Yeah, there's some important because I know there's everyone in here still has notes. Everyone in here is going to take this test coming up here soon. So we might need to know some importance about the R value. It's the best fit for data points on the scatter plot. Yeah. It's almost like it's on the front of there, right? But what else does that give me? What do I want? What does that tell me? What does that R value tell me? To the what? Yes, very good. It's how close it is to the equation. What do I want my R value to be? If it is a perfect line connecting all the dots, what's my number? What's my R value going to be if it's perfect? Come on, there's got to be at least one thing you guys remember from Friday. Huh? 1. It's close to 1 because that's 100%. It fits at 100%. So if your number is 1, that means it is 100% fitting everything.
So that's pretty close.
Is 0.9995 really close to 1?
Yeah.
Yes, it is. So this is a good fit. So I'm going to write out negative 11.6 plus 13.4 ln x.
Hey, that's pretty easy.
Now, every time you do one of these regressions, you need to look at the R value. You need to look at that to tell me which line fits better. Okay, and I'm going to show you why. So this is a, what type of regression was this? Okay. So let's try a different one just for the sake of looking at my different regressions. I'm going to change my model. Oh, let's go quadratic to see what it gets. Okay, not bad.
Not bad, not good.
Let's see what this one says. No, it only has an R squared value. R squared means it is going to be the positive and negative, how it fits. So R squared value is not as good. All right, let's check if it's linear. It's not linear, but let's see why.
Oh, yeah.
Look at my R's compared to the R's I had a minute ago. This R says 0.961. So if I had to choose in between the two, which one would I choose? Would I choose the logarithmic? I would choose the logarithmic that we actually had, not linear, because my R value here for this one is 0.9995. So going through this, all you have to do, especially with this calculator, is plug it in, check to see which one actually fits best. That's all you have to do. And then write the equation for this. So I'm going to stop here because I want you guys to actually work on this. I know there is some more stuff to go with this, but it's the same thing for quadratic. So make sure you all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff at the merch store.